Good morning. I am Vijay Madhavi. In this session, we'll learn about CSMA by CD. That means it is one of the random access protocol. In random access protocol, we have Aloha, CSMA as well as CSMA by CD and also CSMA by CA. And in the last session, we have learned about what is meant by Aloha protocol as well as CSMA. And in this today's session, we'll learn about what is CSMA by CD. Here, this carrier sends multiple access by collision detection. It is a network protocol. It is mainly used for the transmission of data frames. Okay. It is a network protocol. It is mainly used for the transmission of data. Okay, friends. And in this CSMA by CD protocol, it works with a medium access protocol layer. Okay, let me see here in the last session also we have learned about what is meant by MAC, medium access control. Whenever if we have this medium access control means if multiple stations are transmitting the data at a time, okay, this medium access control is going to control the data and it is going to send the data in a proper way. Okay, let me see here this CSMA by CD, this collision detection protocol. It mainly works with the medium access control layer. Okay, therefore it first senses the shade channel before broadcasting the frames. And if the channel is idle, then it transmits a frame to check whether the transmission was successful or not. Okay. And if the frame is successfully received, okay, the station is going to send another frame. Okay. If any collision is detected in this collision detection, the station sends a jam or stop signal to the shade channel to terminate the data transmission. Let me see here in the last session in the MAC, what I have explained in the MAC, if multiple stations are transmitting the data, then this medium access control protocol, it is going to transmit in a proper way. Then in that only we have this random access control protocol. In the random access protocol, we have this Aloha CSMA, and in this CSMA by CD, this here, this protocol works with a medium access control layer. Therefore, it first senses the shade channel before broadcasting the frames. And if the channel is empty, it transmits a frame to check whether the transmission was successful or not. Okay. And if the frame is successfully received, okay, the station is going to send another frame. And if any collision is detected in the CSMA by CD, the station is going to send a jam or stop signal to the shade channel to terminate the transmission. Okay. After that, it is going to wait for a random time before sending a frame to a channel. Okay. And now here we have, in this, we have to learn about this. In the last, we have learned about collision detection network protocol. Now we'll learn about collision avoidance network protocol. In this CSME only, we have collision detection as well as collision avoidance network protocol. This collision avoidance network protocol is mainly for the carrier transmission of data frames. Okay, it is a protocol that works with a medium access control layer. When the data frame is sent to a channel, it receives an acknowledgement to check whether channel is clear. Okay. Here in this collision avoidance channel, here when a channel is transmitting the data, that means when a data frame is sent to a channel, it is going to receive an acknowledgement. That means the sender is going to get the sender will get an acknowledgement from the receiver. Once the sender is sending the data, after getting the data from the receiver, it is going to get the acknowledgement. Okay, it receives an acknowledgement to check whether the channel is clear or not. Okay, and here in this collision avoidance, that means in the CSME by CD, we have some methods. In those, the first method is interframe space. What is this interframe space? In this method, the station waits for the channel to become idle. That means whenever if sender is sending some data, okay, that means here we have multiple stations we can call, or else we can call it as stations, okay. And here in this method, the station waits for the channel to become idle. If it gets the channel is idle, it does not immediately send the data. That means instead of this, it waits for some time, and this time is called as interframe space, okay. Or however, the AFS time is often used to define the priority of the station. Okay. And next, that means which channel is empty and which station has to send the data. Okay. That is going to be calculated at the interframe time space. Okay. And next here, what is meant by this contention window? The total time is divided into different slots. when the sender or station is ready to transmit the data frame. It chooses a random slot, number of slots as wait time. Okay. If the channel is still busy, it does not restart the entire process once again, except that it restarts the timer only to send some packets when the channel is inactive. Okay. And what is mean by acknowledgement? For example, now the sender is sending some data. Okay. So sender sends the data frame to the shared channel. If the acknowledgement is received, okay. If the acknowledgement is not received ahead of time. Okay. And next here, like we have three different types of channels. The following are the various methods to access the channel based data on the time, distance, and code. Okay. That means here we have, it was mainly divided into three types: frequency division multiple access, time division multiple access, as well as code division multiple. What is meant by FDMA here? Here we have the different channels are transmitting the data. Okay, just see here in the frequency division multiple access method, this is mainly is to divide the available bandwidth into equal bands so that multiple users can send the data with a different frequency to the subchannel. Each station is reserved with a particular band to prevent the crosstalk between the channels and interferences of stations. Let me see here in the frequency division multiple access, what happens? This method is used to divide the available bandwidth into equal bands so that multiple users can send the data through a different frequency to the subchannel. Okay. And here each station is reserved with a particular band to prevent the crosstalk, okay, between the channels and interference of the station. Okay. That means here the complete is going to be divided into as per the frequency it is going to be divided. Okay. And next, what is meant by this time division multiple access? It is also an access method. It allows the same frequency bandwidth to be shared across multiple stations. The same frequency bandwidth is shared across multiple stations. And to avoid the collision in the shared channel, it is going to divide the channel into multiple different frequency slots that allocate the stations to transmit the data frames. The same frequency bandwidth into shared channel by dividing the signal into various time slots to transmit the data. And next here in the first we have frequency. Okay, that means that bandwidth is divided into frequency. Next it was divided into time. Now we have, it was divided into code. That means the code division multiple access is the channel access method. In this code division multiple access, all stations can simultaneously send the data over the same channel. Okay, that means it allows each station to transmit the data frames with full frequency on the shared channel at all times. That means it does not require the division of bandwidth or a shared time. Okay. And if multiple stations send data to a channel simultaneously, the data frames are separated by the unique code sequence. Okay. In the next session, we'll learn about the network layer. See you in the next session. Thank you.